Okay, last time we were talking about source code, excuse me, we were talking about the asymptotic Euclid partition property, we were talking about how entropy relates to probability, and we were talking about basically how to create a source code based on the idea of a typical set. So a typical set, you'll remember, is the set of all sequences that are that have, in some sense, the average probability. And we noticed that almost all of the likely sequences had roughly the same probability. So today that's sort of the top-down view of source coding. In other words, we start with the typical set, and we argued that what we can do is we can enumerate the members of the typical set and create a source code that way. Now we're going to take the opposite view. We're going to go bottom up and say we're going to try to create some practical source codes, and we will show that they are in fact optimal. They achieve the end result. So let's define a few things related to source codes. So we have a random variable x, and the idea is we want to encode the outcomes of x in a source code. So the sample space of x is the set script x. This is the set of possible outcomes of the random variable x. And we will let u represent a set of symbols allowed on the channel. So if you think back, 3 lectures ago, we introduced some example source codes. The example we saw was a grading system. So there, the sample space was a set of grades. We had A plus, A, B plus, B, and so on. Each of which were assigned certain probabilities. So these were the set of possible messages that we could have. And the encoding alphabet was binary. So what we did was we took binary strings and assigned them to each of the possible outcomes in the sample space. Okay. In particular, being a little more formal, so we have U as the set of all possible symbols allowed on the channel, and we will let U star represent all finite length sequences in U. What do I mean by that? Well, if U is binary, then the set of all finite length sequences of U, well, you can have a sequence of 1. So here's 2 possible sequences. Those are the sequences of length 1. The sequences of length 2 are these. Sequences of length 3, and so on and so forth. Anyway, you get the idea. So, U star is the set of all possible finite length sequences of U. So a source code, the formal definition of a source code is a mapping from the sample space of the outcomes X to the set of finite length strings of the channel alphabet. And we saw this again. Think back to my example from 3 lectures ago to make sense. We had sample space of all those grades, and we assigned each of them some finite string of binary letters, which all obviously belong to this set U star. And the source code was the way we mapped each grade into some finite sequence. Okay, so this function, this mapping, we will give it a functional representation C of X is this mapping. In other words, if I have an outcome of the random variable X, then C of X gives me the corresponding string in U star. And sometimes we would write the mapping notation might look like this. C is a function from X to U star. Okay, there's another property which we've touched on, which is average length. So the length of each code word is the length. L of X is the length of C of X. So in other words, if I have some encoding, there's some letter in X that arises in if for some X, Cx is equal to 0, 1, 0, 1, then the length is 4. So this is just the number of these channel symbols that are in each representation for each outcome X. Some further terminology. The outcomes of the function C of X are called code words. So these are the allowed code words that you use in your source code. This is also something we've already talked about, but formally the expected length of the code, of the source code, written capital L of C. Now this is a function of the code, is given by L of C is equal to the sum over all possible outcomes of the random variable of the probability of that outcome times the length of the encoding. So again, that's something we've already seen. The idea is to find C, this mapping C of X that minimizes this length, this average length.